Today I will show you how you can square a 3x3 matrix faster and with less writing effort. Make sure to watch my video about squaring a 2x2 matrix first, because you will need the 2x2 squaring approach in this video. Let's take a look at the following general 3x3 matrix. We will now arrange this matrix in a particular way, like that. We will call this submatrix here A. So this submatrix here is A. This vector here we will call B. So this vector here is B. This row vector here we will call C. And this value here, I, doesn't get a new name. Okay, so we have I here. Now we have this block matrix here. We can now square the matrix B. We will apply the approach for squaring a 2x2 matrix to this block matrix here. But we have to take care to apply it correctly. Principally, we will do the same thing as we would square a 2x2 matrix. So B squared has to look like this. B squared is equal to A squared plus some product P1 T times B where T is some kind of a trace, C times T and I squared plus some product P2. A difference to the last video is that we now have two different products, P1 and P2, of these two values. There is a simple reason for that. We have two options to calculate the product of B and C. The first option is B times C. So B times C. Which is a 2x2 matrix, because B is a 2 times 1 matrix as a vector, and C as a row vector is a 1 times 2 matrix. So we get a 2x2 matrix by calculating this product. This product is also called the tensor product of the vectors B and C, and it is written like that. B tensor product C. And this is a 2 times 2 matrix. The other option to calculate the product of B and C is to calculate C times B. This is a 1 times 1 matrix, which is a scalar, because C as a row vector is a 1 times 2 matrix, and B as a column vector is a 2 times 1 matrix. So C times B is a 1 times 1 matrix. This product is also called the scalar product or dot product of the vectors C and B. Now it should be easy to see which of these two products is P1 and P2. P1 has to be a matrix, because A squared is also a matrix, and this sum here has to make sense. So P1 has to be a matrix too. So P1 is the tensor product of B and C, because P1 has to be a 2 times 2 matrix, and P2 has to be a scalar, because I squared is a scalar. So P2 has to be the dot product of C and B. The last thing I have to explain is the value T. In the 2 times 2 case, it was the trace of this matrix here. Here it is very similar. T is the sum of these two entries of the block matrix, A and I. So T is equal to A plus I. But right now this sum doesn't make any sense, because A is a 2 times 2 matrix and I is a scalar, so a 1 times 1 matrix. So this sum doesn't make any sense right now. So we have to multiply the scalar I with another matrix. This matrix is the unit matrix E2. So the matrix T is equal to A plus I B D and E plus I. So to calculate the matrix T, just have to add the scalar I to these two entries. Also note that here in this product T is on the left side, and here this product T is on the right side. This is important because T is a matrix. In the 2 times 2 case this was not important, but here we have to make sure to get the right order. To make the approach a bit clearer, we will now take a look at an example. Because it's the first time we apply the approach, I will calculate all the numbers step for step. So I will calculate t, p1, p2, and also the matrix A squared. Okay, here is the example. We want to square the matrix B. First thing we have to do is to arrange the matrix B in that way. Now, this here is the submatrix A. This here is the vector B. This here is the row vector C. And this here is the scalar I. Now we have arranged the matrix B in this way. Okay. The first thing we do is to square the 2 times 2 submatrix A. So this here. Because we need A squared here. I will square the 2 times 2 submatrix A by applying the approach I showed you in my last video. So A squared is equal to 1 squared plus P, which is 0 times 2. So the first entry is 1. This entry here is 1 squared plus 0 times 2. So also 1. This entry here is 0 times t, which is 1 plus 1, so 0. And the last entry is 2 times t, which is 1 plus 1, so 4. The next thing we calculate is the product P1. So P1 is equal to B times C. And this is a 2 times 2 matrix. So the first entry of this matrix is 1 times 1, so 1. The second entry is 1 times 1. This here is that here, so also 1. There. This entry here is 0 times 1, so 0. And the last entry here is 0 times 1, also 0. So this matrix here is the product P1. Product P2 is equal to dot product of B and C. So C times B. This is a scalar. So C times B is equal to 1 times 1 plus 1 times 0. And this is equal to 1. We also need the sum of these two entries. So the submatrix A with I. So T is equal to A plus I times 2, the unit matrix. 2 times 2 unit matrix. And this is equal to, well, we just have to add this number I to these two values and we are done. So 1 plus 1 is 2, 0, 2, and 1 plus 1 is 2. So this here is the matrix T. Now we can square the matrix B. B squared is equal to A squared plus P1 T times B C times B, C times T and I squared plus P2. So at first we calculate A squared plus P1. So this is the sum of this matrix with that matrix. So 1 plus 1 is 2, 0 plus 1 is 1, 4 plus 0 is 4, and 1 plus 0 is 1. The next thing is T times B. So B is this vector here, and T is this matrix here. We just have to insert the vector B in the matrix T. So T times B is just 2 and 2. So this vector here, 2 and 2. For these entries here, we have to calculate C times T. So C is this row vector here, and T is this matrix here. We can just insert in the transpose of the matrix T. Or you can calculate this product C times T like this. 1 times 2 plus 1 times 2 is 4, and 1 times 0 plus 1 times 2 is 2. The last thing we have to calculate is I squared plus P2. This is 1 squared, which is 1, plus P2, which is 1. So 2. Now we've found the matrix B squared. Okay, let's take a look at another example, but this time we'll follow the approach a bit faster. So, first thing we have to do is to arrange the matrix in that way. we want to square the matrix B. So for the first 4 entries, we have to calculate A squared. So we have to square this submatrix here and add P1, which is the product of this vector with that vector. So we have to calculate for this first entry here 1 squared plus 2 times 0 plus 1 times 1 is 2. For this entry here, we have to square 1, which is 1, plus 0 times 2 is still 1, plus 2 times 0 is 1. For this entry here, we have to calculate 2 times 1 plus 1 is 4, plus 1 times 0 is 4. And for that entry here, we have to calculate 0 times 1 plus 1 is 0, plus 2 times 1 is 2. To get the matrix T, we need to add 3 to these two values. So I will do it like that. I will erase these two entries and just add 3 to them. So 4 and 4. Now for these two entries, I just have to plug this vector b, 1 and 2, into this new submatrix here. So this entry here is 4 times 1 plus 2 times 2, which is 8. And this entry here is 1 times 0 plus 4 times 2, which is 8. For these two entries here, I have to calculate C, so the vectors 1 and 0, times this matrix. I will do it like this: 1 times 4 plus 0 times 0 is 4, and 1 times 2 plus 0 times 4 is 2. And for this last entry here, I have to square 3, which is 9, and add the dot product of these two vectors. So 1 times 1 plus 0 times 2, which is 1 plus 9 is 10. And now we have found b squared. I hope my video will help you to square a 3 times 3 matrix faster and with less writing effort. Maybe I will make another video where I will show you how you can square a n times n matrix faster and with less writing effort.